Hi group. Last lesson of chapter 14. We only had 2 lessons here. So we talked about square roots. Now we're going to talk about cube roots. Again, hopefully you wrote that list out of cubes and cube roots to help your life out a little more, make it easier. Do all that workload, take the time to do that so then it sets you up and makes life easier. And hopefully it'll make life easier as you go through these examples with me. Let's go through some key ideas. So when you multiply a number by itself twice, you cube the number. So the symbol for cubing is the exponent 3. So when I see 4 to the 3rd power, I would say that's 4 cubed. What that means is I have 4 times 4 times 4, multiplying 4 by itself 3 times. So my answer here would be 64. To undo this, so the opposite or inverse of cubing a number is to take the cube root of that number. So the symbol for cube root is just like a square root, but we added this little 3 in the corner. That shows us that it's a cube root, not a square root. So when I take the cube root of 64, that equals 4. And again, instead of you having to sit there and think, oh, what number do I multiply together 3 times to get 64? You should have that list in front of you of cube roots so you can automatically look at it and say, oh, cube root of 64, that's 4. So this is just easy access for you so that you're not stuck sitting there trying out numbers and wasting time. Hopefully you have that all written down. If you don't yet, I would make that list. So again, a cube root of a number is a number that when multiplied by itself and then multiplied by itself again equals the given number. A perfect cube is a number that can be written as the cube of an integer. So all of those cube roots that you wrote on that list, 1 through 25, those are all perfect cube roots. Lastly, again, the symbol is used to represent a cube root. So don't forget it. If you want to represent a cube root, you need that little 3 above the little, almost like the little check mark part of your root symbol. So let's find each cube root. You might have that list in front of you and easily be able to think, what number do I multiply together 3 times to get 8? That would be 2. 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. What is the cube root of a negative 27? So you might be looking at your list and say, oh, well, the cube root of a positive 27 is 3. But now if I want it to be negative, then that number has to be negative. And you can check yourself. If I multiply a negative 3 together 3 times, this gives me positive 9, and then this gives me negative 27. Last one, we have a fraction under there. I can maybe take a look at my list. Are these perfect cube roots? Well, I know the cube root of 1 is 1. And the cube root of 64, which we did it earlier up at the top, is 4. So I'm good to go. My answer is 1/4. Let's evaluate expressions involving cube roots. Again, I would take care of your cube roots almost like an exponent. We do those things first. So cube root of a negative 216. Again, this is why it's nice to already have that list made in front of you. Cube root of a negative 216 is negative 6. Now we do our multiplying. So 2 times negative 6 is negative 12. Negative 12 minus 3 gives me negative 15. Now remember, taking the cube root and cubing a number, that all cancels out. I'm just left with what's underneath. Again, if you wanted to do your parentheses and take the cube root of 125 and then go and cube it, that'll just get you back to here at 125. Okay, so either way works, whatever steps you need to take to get there. And now just add these together. 125 plus 21 gives me 146. I'm going to give you some time. I want you to pause the video and try these 2 examples. Once you're done, play it again and we'll go over it. So let's take a look at this first example. This cube root here is over this entire fraction, negative 27 over 1,000. So what I'm going to do is break that up into, I'm going to take the cube root of each number. So the cube root of negative 27 and then the cube root of 1,000. That's going to give me a negative 3 and 10. Next, I'm going to do my cube root first, the cube root of 512. Hopefully you looked at your cheat sheet. When you take the cube root of 512, you get 8. Now let's multiply and then subtract. Should have gotten 21. All right, we got a few more, or I think one more example I want to do with you in this video. So let's look at the next page at the top, example 3. If I ask you to evaluate this expression when x is 192. So when I ask you to evaluate an expression, we're going to replace x with 192. So let's do that. Now, take a look at your cube roots. Is there a perfect cube root for 192 or 3? Well, I know there's not one for 3, so I know I don't want to break this up into two separate cube roots, the top and bottom. So maybe we have to actually divide them. So go ahead and evaluate 192 divided by 3. That should give you 64. And I know I can take the cube root of that, which gives me 4. But now let's deal with what we still have in front. Can I simplify 192 over 4? Well, go ahead, divide those, and you get 48. 48 plus 4 equals 52. And that's our answer. That's the expression evaluated. Again, just like in the first lesson, example 4, our real-life application problem, I'm going to skip it just for the sake of time, and also I don't want to stress you out at home. You know, it's talking about volume and it's talking about surface area, and we haven't really